Hello everyone and welcome back to the channel. In today's lesson we're going to be exploring one of the key building blocks of AWS infrastructure, load balancing. So if you've ever wondered how massive sites like Netflix or Amazon handle millions of user requests every second without crashing, the answer is almost always load balancing. We'll look at what it is, why it matters, and the types of AWS provides that makes your application more scalable, reliable, and secure. So what is a load balancer? Let's start with the basics. What does a load balancer really do? A load balancer is like a traffic controller of your cloud environment. It sits in front of your application servers and decides where each incoming request should go. If you only had one server, all requests would pile up there, and if it failed, your entire site would go offline. A load balancer prevents that by spreading requests across multiple EC2 instances, making sure no single instance becomes overloaded. You can think of it like a restaurant host who distributes guests evenly among available tables, keeping service smooth, fast, and organized. Next, we'll move into the load balancing advantages. So what are the main advantages? First off, it exposes a single entry point for your application using DNS, simplifying how users connect. Second, it will ensure fault tolerance. So if just one server fails a health check, traffic can automatically shift into new healthy ones. It also provides SSL termination, which offloads the heavy encryption work from your application servers. You can enable stickiness so that a user stays connected to the same backend instance during their session. And because AWS load balancers operate across multiple availability zones, they give your application high availability by default. So this setup keeps your app resilient. Even if an entire zone goes down, traffic is automatically rerouted to others. Next, we'll look at AWS Elastic Load Balancing. So AWS offers a managed service called Elastic Load Balancing, or ELB. This means you don't have to install, patch, or configure a load balancer manually. AWS handles the maintenance, scaling, and high availability, so your focus stays on your application, not the infrastructure. It's integrated with other AWS services such as EC2, auto-scaling groups, and ECS, allowing for automatic registration and deregistration of instances. So while it's possible to build your own load balancing setup, that's usually more expensive in terms of time and complexity. ELB gives you reliable performance with just a few configuration options, and it automatically scales to meet your traffic demands. Next up, we have health checks. So health checks are one of the most important features of any load balancer. So they're used to test whether an instance is available to handle those requests. So a health check targets a specific port and route, often something like /health. If the load balancer doesn't receive a 200 OK response, that instance is considered unhealthy and is temporarily removed from the rotation. This means your users will never be sent to a broken or a slow server. AWS will constantly monitor and react in real time to maintain stability. Next up, we have our types of load balancers. So AWS provides 4 main types of managed load balancers, each designed for a specific purpose. First off, we have our classic load balancer. This was the first generation, introduced in 2009. It supports HTTP, HTTPS, TCP, and SSL, but has largely been replaced by newer models. Next up, we have our application load balancer, or ALB. Launched in 2016, this one operates at the application layer, which is layer 7. Perfect for your modern web applications, APIs, and microservices. Then we have a network load balancer, which was introduced in 2017. It operates at the transport layer, layer 4, handling TCP, UDP, and TLS traffic. It's built for ultra low latency and can handle millions of requests per second. Lastly, we have our gateway load balancer, or GWLB. This one was added in 2020, and it operates at the network layer, layer 3. It's often used for routing traffic through third-party appliances like firewalls or intrusion detection systems. So when do you use each of these? You use your application load balancers for web traffic and APIs, basically anything that uses HTTP or HTTPS. You use your network load balancer for applications that require extreme performance or use custom protocols over TCP or UDP. Your gateway load balancers are great for integrating security or network inspection tools. and your classic load balancers are mainly for legacy systems that haven't been upgraded. In general, AWS recommends using an ALB or NLB for all new deployments since they offer the most flexibility and the most modern features. So to recap real quick, load balancers are the first line of defense in scaling your AWS applications. They distribute incoming requests, detect unhealthy servers, secure traffic through SSL termination, and keep your system reliable across multiple zones. When combined with auto-scaling, they become the backbone of a high-availability architecture in AWS. In the next video, we'll build on this by digging deeper into the application load balancer and network load balancer, learning how they handle advanced routing, integrate with SSL and TLS for security, and automatically connect with auto-scaling groups to manage traffic fluctuations in real time.